So we're here to see why it is very easy to prove that when you have an equilateral triangle, that is a triangle where all of the edges are the same length, all of the angles in the triangle must be identical. This is actually true for all regular polygons. Here are a few examples to the left and to the right of the equilateral triangle. And if you'd like to know why that is, I've made an in-depth video explaining that, and it's linked in the description and comments section. So let's focus on the equilateral triangle to show why all of its angles are identical. We know that for this type of triangle, all of the edges are the same length. We'll just label all of the edges with an L. I'm going to remove all of the angle labels for the moment because we haven't proved that they're identical yet. And for the moment, I just want to focus on the length of two of the edges. So let's ignore the base length. And so the two remaining edges are the left edge and the right edge, which are of equal length. We know that the definition of a triangle with two equal lengths is an isosceles triangle. So we can identify the triangle as such by putting a couple of markers in. Now, since these sides are identical, we know that the base angles in this triangle must be identical. Their precise value is insignificant, so I'm making them the same color to show that they are equal. We could actually think of the base angles in another way, and that is when two edges are equal, the two angles opposite those edges are identical. There's just one more step we have to do. Let's bring the length of the base back. I'm going to hide these two indicators for the isosceles triangle, and then I'm going to hide one of the other two edges, leaving the base and that edge. It doesn't matter which edge we get rid of, so I'm getting rid of the left edge, and we're left with a similar scenario as before. Two edges that are equal in length. Again, we have an isosceles triangle, so let's indicate that. And if you remember, we said that one way of talking about the angles in an isosceles triangle is that when you have two edges of equal length, the angles opposite those edges must be equal. Well, the base of the triangle and the edge on the right are equal in length, so the angle opposite the right edge and the angle opposite the base must be identical. And that leaves us the result that the three angles in the triangle are identical. And that's how simple it is to prove that all the angles in an equilateral triangle are of equal value. Now, a few of you might be thinking, but this isn't an isosceles triangle, it's an equilateral triangle. And in order to ease your doubts, let's look at the definition on the wiki page for isosceles triangles. So here we are on the page for isosceles triangles, and let's see what the definition says. It says, in geometry, an isosceles triangle is a triangle that has two sides of equal length and two angles of equal measure. Sometimes it is specified as having exactly two sides of equal length, and sometimes as having at least two sides of equal length, the latter version thus including the equilateral triangle as a special case. So it's perfectly acceptable to view an equilateral triangle as isosceles, and therefore our proof is valid. If you're curious about why for the rest of the regular polygons all of their internal angles are identical, feel free to check out my video covering that subject, linked in the description. Well, that's it for now. Thanks for watching.